Hi, this is Adam Griffin with the second video for this week. So we're going to be doing problem number 3, which deals mostly with pressure, and it kind of hints a little bit in this last part about some more advanced physics dealing with neutrinos, and we'll get into that at the very end of this video. So number 3 goes like this. So the IceCube cosmic ray detector is based on light sensors buried underneath the Antarctic ice, and holes are drilled in ice using hot water to create cylindrical cavities filled with liquid water, which are as deep as 2,450 meters. So while the water is still liquid, instruments that can detect light flashes from cosmic rays are lowered into the water and eventually are frozen back into the ice. We have to find the gauge pressure at the bottom of one of these holes with a depth of 2,450 meters. Before it freezes again. So we're using the density of water to get this. So we take the density of water, 1,000 kilograms per meters cubed, and our gravitational constant, 9.8 meters squared per second squared. And then we'll talk about this at the end. So our gauge pressure we know is equal to our pressure minus the pressure of the atmosphere. So 1 atmosphere in pascals is equivalent to 101,300 pascals. So that's what we'll be plugging in here. And then to find the pressure, we have to multiply the density of the water, so 1,000 kilograms per meters cubed, times our gravitational constant, and then times the depth of our hole. So we can plug in all of these values, so 1,000 kilograms per cubic meter, 9.8 meters per second squared, and 2,450 meters. So we get that our pressure before we do anything to it is 2.4 times 10 to the 7th pascals. So if we subtract 101,300 pascals from that, we get our gauge pressure, which we find is equal to 2.39 times 10 to the 7th pascals. So that's our gauge pressure at the bottom. And then at the end, it asks why the physicists are drilling these holes. So basically, they're trying to detect neutrinos, which are little tiny particles that fly through space. And down at this depth, the ice is super clear, and also it blocks out, this thick layer of ice blocks out all of the other little particles or light that might interfere with the instrument. So because they're targeting very high energy particles, they will be able to travel all the way to the bottom, and it kind of just makes it easier because there's not as much disturbance by other things hitting the sensor. So that is how you do number 3. I hope it was clear, and thank you.